Page 3 says a degree 5 polynomial that has these zeros, a plus 3 and a minus 3. So this polynomial would have to have a factor that's got x minus 3 for plus 3 and x minus a minus 3 for the minus 3 and x minus a minus 2, which is x plus 2 for the minus 2, and x minus this imaginary 0, so that's x minus, and if I'm going to subtract a 1 plus 3i, that becomes minus that whole thing, so it's minus 1 minus 3i. And if I have 1 0, that's 1 plus 3i, its conjugate also has to be a 0. So I have one more here, that's 1 x minus, and if I do the minus of this, it's going to be minus 1 plus 3i. And that's that one. Number 4. So I'm going to get a feel for what this looks like. So it goes through positive 2. Actually, it doesn't go through. It's a positive 2 that's right here, but it bounces. It goes through, see, 1 minus x would go through 1, because 1 minus 1 would be 0, so 1. It goes through 1, and it happens only once. It's not squared or anything, so it's got to go through. And straight through, but I'm just going to write through. And x plus 3 must go through negative 3. And it's cubed, so it must hesitate. Okay. And this is what degree? Well, we have x times x from the square times a negative x times x times x times x, because it's cubed on that last one. So I get a negative x cubed. Well, x to the 6th. X to the 6th is even power, so even degree, so either both ends are up or down, but since it's got a negative from that x, 1 minus x, a negative, both ends must be down. So if it hesitates at minus 3 and it's coming from below, it must come up, hesitate, and then go on. So it does a waver there, and if you were to actually plug this into the calculator into y1, you'll see that waver. Then it goes on up, and it goes up quite a ways, and it comes back down through at 1, which it's supposed to go straight through at, as we said. And then it's supposed to come up and bounce at 2. So it's got to come up and bounce and then keep on going down. And both ends are down because it's an x to the 6 and negative. So, what part of this polynomial is greater than or equal to 0? Well, all of it between negative 3 and 1, all of that is greater than 0 and equal to 0 at negative 3 and up to 1. And a lot of you got that part right. But it can be equal to 0, and it happens to equal 0 right at 2, and so we have to add in from 2 to 2. The book uses just a single 2 in there, but I like to do the interval from 2 to 2. Okay, so that's the solution. And finally, number 5. So just going from left to right, it goes through minus 1 to minus 3, so it means a factor is x plus 3. And we're trying to find the function. And there might be a stretch or shrink factor a, so I'm going to put that there. It goes straight through at minus 1, so that means x plus 1 again to 1 power, because it went straight through, straight through. It then bounces at positive 1. So that must be x minus 1 twice. And then it bounces at, or goes straight through at 3.9 or 4 or something like that. I'm just going to say it's 4 approximately, because it says get something that roughly looks like this. So I'm going to say it's x minus 4, just for convenience. You use 3.9 or 3.8 or 3 3/4 as some of the things I saw. That's fine. So now we've got it looking good, except for I wanted to same y-intercept. Well, that y-intercept is 0, -2. It's on the lower side. So if I put -2 in for f, equals a times, put 0 in for x here and I get 3, 0 in for x there I get 1, 0 in for x there I get 1, and 0 for x there I get -4. So I got -12a equals -2. Divide by -12, divide by -12, and I get a equals 1/6 positive. And so now I can put that back in there and I get the function to be 1/6. Now if you use something other than 4, you might get like 3.9 or 3.8 in here. And it makes this a little bit smaller and it makes this a little bit bigger number here than 1/6. But that's close. And then we have x plus 3, x plus 1, x minus 1 quantity squared, and x minus 4. And now we're done.